Okay, I wanted to do a little recording to kind of give you some assistance in understanding and going through the information in the trig unit for Algebra 2B at 6.1 through 6.5. And so what I want you to do is to go through the online lesson carefully, take notes, read the examples in the book carefully, take notes, make sure that you're clear about what it is you're trying to do, and complete the practice problems. It is imperative that you practice these skills. They are not going to come easy, and it's stepping into the next realm of math. So it's not going to be something that you've done before. It's not going to be anything that you've seen and that you can rely on knowledge that you have in the past. So that's why I wanted to do this. I know I'm going to be out of town, and I'm making this for the spring of 2013, so I may use it later on. But and I wanted to make sure that you are clear about some things that we may not have time to talk about in live lessons since I'm going to be out of town for those 2 weeks of testing. If you're watching this and it's not spring of 2013, that may not apply. Okay, so let me kind of start from the beginning. And this is just going to be kind of the big picture nugget. So that's why I'm saying this does not replace working through the online lesson. So please know and be aware of that. All right, the first lesson that they're talking about is the unit circle. Everything in trig is based on the unit circle. And the unit circle is just a circle that is centered at the origin and can be measured in radians or degrees. And you always start at 0 right here, okay? And you're going to measure typically going counterclockwise. Okay, so if I wanted to get to 90 degrees, I would go clockwise, and then this axis is considered a 90-degree angle. So from here to here makes a 90-degree angle. Well, you know that. That's not that complicated. And then from here to here makes a 180-degree angle, and from here to here makes a 270-degree angle. So, and then there's angles all in between. So we could put an angle right here in the middle. That would be a 45-degree angle. So a 45-degree angle could be right there. So this angle, and it's always the x-axis and then the angle measure. You're never going to measure your angles. Let me show you. You're never going to measure them in this part. It's never the y-axis and the angle. It's always the x-axis and the angle. So if you're measuring this angle, the reference angle is right here. Okay, it's never the y-axis. It's always either going down from the x-axis or going up from the x-axis. Let's say I put an angle right here, and this was a 30-degree angle. See, I've got my lovely little triangle. That can be your reference angle. Now, the measure of that, let me get a different color here, starts here and it goes all the way around. Well, we know a circle has 360 degrees. So this line, or this at this place, is a 330-degree angle. However, if you're trying to see what the reference triangle is, and you're going to do some work with that, you always drop that line, that perpendicular to the x-axis. So the 30-degree is what we would call the reference angle. I'll just abbreviate this part, the reference angle, and I do my little angle with a little thing in between it so it doesn't look like a less than. But the measure of that angle is 330 degrees. So just know that when you do reference angles, you always drop the perpendicular to the x-axis, always to the x-axis, okay? Don't ever make your reference triangle look like this, where your perpendicular is right here at the y-axis. This is not going to give you correct work, and it's not going to turn out the way you need it to turn out. It always goes to the x-axis. So if you're in the third quadrant, you would have your angle here, and if you were drawing your reference angle, you drop it up to the x-axis, always to the x-axis. If you're here, you'll drop it down to the x-axis. So think about it, it's kind of making a bow tie. So whichever quadrant you're in, your reference angle will always be oriented to the x-axis. Never, see, I don't have anything oriented to the y-axis. when you measuring those angles, you definitely start at 0 and go counterclockwise. Okay, we could always also call this angle, so this is a 330-degree angle. Here's another vocabulary word for you. The coterminal angle for that could be called negative 30 degrees. So if you have an angle measure that's negative, that is what tells you to go clockwise. Clock. So if your angle, ooh, that's an S. So if your angle is negative, that's your indicator that we're going to count this in the clockwise direction. So the negative is a directional thing. So any positive angles get measured this direction. Any negative angles get measured in this direction. All right, so that's that. Now I'm also going to post a recording that I've already done in the past about the unit circle and radian measure and degree measure. It's very, very important that you understand where the unit circle comes from. I think I have a copy of that. Hold on, let me look at my file pods here. Maybe I don't. I can share it with you. I'm going to share with you a unit circle. I'll do it. I'll do it in a minute. I'll post it with this when I post this on the message board. I'll put the unit circle file with it. Um, it. And you can have the unit circle to look at and use, but you've got to know where it comes from. So it's really important that you watch that unit circle recording, you do those unit circle practice problems, and you really get a good grip and a good understanding of what the unit circle is, what the information on it tells you, because that's going to help you a lot. So let me share with you, I think I have it right here. Oops. Let me share with you my little unit circle here. And I know I have it. Where's it at? Where's it? There it is. I hope this one works. Yeah, there it is. Okay, so this is the unit circle, and you're like, oh, wow, what is all that? This is a lot of information. That's why it's really important for you to study this and understand where it comes from. And I'm not going to go through that in this recording because I've got another recording that I'm going to post for that. So make sure you watch that. If this is confusing you and you're like, oh my goodness, what is all that? You really want to watch my recording on how to create the unit circle and the explanation of where all these things come from. What I'm going to talk about right here is how it relates to the graphs that you're going to be doing in Unit 6. But you have to understand this in order to do that. So make sure that you stop right here. Make sure you're clear about the unit circle. You might need to go and review that other recording. You might need to look through that online lesson more about the unit circle. But then once you get that, then you're ready to come back to this and you can fast forward to this point and then move forward. Okay, so this is our unit circle. And what we're going to do is we're going to take this information and we're going to put it on a graph. So we're going from the circle and we're kind of going to take our circle and we're going to lay it out and put it on a graph. And so all of the values here are really important when you're doing your graph. So let me make this smaller and open up another one so I can show you what we're doing with the graphs. Okay. And you really have to know what you're talking about. And it's kind of cool. Once you figure it out and you start seeing the connections, it's like, oh, wow, that's awesome. You know, to see how everything connects and how it all goes together is very cool to me. Okay, we're going to stop sharing that. We're done with that. Let me, ooh, I don't want to do that. I just want to do a whiteboard. Whiteboard, here we go. All right, so now let me get this big enough so we can see it. So what we're going to do is we're going to take the information. Let me scooch me over here so I can make my little whiteboard bigger. We're going to take this information and we're going to put it on a grid. And our grid is going to look like this. And it's going to look like this every single time. Maybe. Oh, draw. It's not letting me draw. Okay, hold on a second. All right, let's try that over. Whiteboard. Oh. It's not letting me do it. Okay. Um, let me just hide that. We'll try a different one. That one's not working right. All right, try one more time. Hold on a second. Share, whiteboard. Right, pencil. There we go. Okay, so what we're going to do every time, we're going to have a grid that looks like this, like an XY axis, but it's going to be really long. This is 0 degrees. Okay, this will be 90 degrees. Now, 90 degrees is the same as pi over 2. Pi is 180 degrees. Pi over 2 is half of that. Okay, this one's going to be pi, and I'm typically going to do these with radian measure. But so don't let the degrees and the radians freak you out. Pi over 2 is just 90 degrees. Whoops, that's not what I wanted to do. So I'm going to, well, maybe I'm not. Yeah, I want to take out the 90. I just want to do these in radians because it's just easier and it makes more sense when we go to do some calculation changes. If you do them in degrees, it's okay. It'll be, it's not wrong. It just, well, all right. And I'm trying, I know that some of you are watching this and you haven't done all the practice yet, so I'm just trying to keep it as clear as possible. So 3 pi over 2, and then 2 pi. Let's talk about what these are. Look at your unit circle over here. Our pi over 2, wait a minute, our 0 degrees is right here, that's 0 pi, okay? Then our 90 degrees is pi over 2, that's half of 180. Pi is the same as 180 degrees, so when that makes sense that the axis is 90, it's half. And then 180 plus 90 is 270. Well, that's just 3 pi over 2. So think about it. If we only have these measures on the axes, this would be half a pi, a whole pi, 2/3 pi, 3/2 pi, and then 2 pi. So 1 over 2, 2 over 2, 3 over 2, 4 over 2. And so that's the division. So if we didn't have any of this other stuff, we would divide this whole circle into 4, and we can count by 4. Half. We can count by half because this is pi, and we're splitting that pi in half. So 1/2, 2/2, 3/2, 4/2. And that's where these measures come from. And I'm really only looking at those axis values when I'm changing my unit circle to a graph like this. All right, so now what does this mean? All right, now the next thing that we have to look at from our unit circle to this is what is, if we're doing, let's say we're doing sine first. We'll do sine, then we'll do cosine. So we're going to graph sine, the regular parent sine theta. Okay, so in these ordered pairs, the ordered pairs always go cosine, comma, sine. And they come from the special right triangles. And I share that in that other recording. So hopefully you've watched that. You're clear about the unit circle and where it all comes from. But remember, the ordered pairs are cosine, sine. They're alphabetical. The cosine is the first entry or the first component, and the sine is the second component. So I am looking for the 0 here, the 1 here, the 0 here, and the -1 here. So what I'm basically doing is graphing those ordered pairs. So at 0 degrees, sine is 0. So I have an ordered pair. At 90 degrees, sine is 1. So I have my 1 here, and there's an ordered pair. At pi, or 180 degrees, sine is 0. See, it's right there in the ordered pair, so I'm back to here. And then at 3 pi over 2, or 270 degrees, sine is -1. So I'll be down here at -1. And then at 2 pi, or 0 degrees, or 0 pi, all coterminal, sine has a value of 0. And I'm just getting that right from the ordered pair. And look, if I connect my dots, I have my sine curve. And how I remember the sine curve is it looks like a roller coaster to me. If this was the landing dock of the roller coaster, I would get on the roller coaster and I would go up, 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 up. You know, the first thing on a roller coaster is always up, 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 and then you hang there for a second, and then you go down. And so that's how I remember sines like a roller coaster. It always starts at 0, 0, and you're always going to have these 1, 2, 3, 4, 5 points that are important, and they come straight from the unit circle. All right, so that's the sine curve. The cosine curve, cosine theta, we're going to have the same markings. We're going to have 1 to -1. We're going to have this one is 0. We're going to have pi over 2, like 1t, it's pi. Then we'll have pi. Remember, pi is just 180. Then we'll have 3 pi over 2. And then we'll have 2 pi. All right, so now let's look at our ordered pairs here. Remember, cosine, the ordered pairs are the first part. So for cosine right here, we want, oh, I don't want green. Let me change it to like a purple or a pink or something. There we go. We want the 1. And for the 1 cosine here, we want the 0. Cosine here, we want the 1 value. And cosine here, we want the 0. So we're just going to go over to our graph over here and plot those. So at 0 degrees, or 2 pi, or 0 pi, cosine is 1. So I'm going to have an ordered pair. And at 90 degrees, or pi over 2, cosine is 0. Remember, cosine is the first part of the ordered pair, so I'm going to have a 0. And then at pi, or 180, my cosine value is 1. That's a -1. Why doesn't that have a -1? That should have a negative. Oh, that doesn't. That's kind of weird. It's a negative. It should be -1. Because if this is 0, 0, we go over -1 and up none. I was like, wait a minute, that doesn't look right. So I'm not going to use that one. That looks like a +1. All right, maybe it's where I've drawn all over it too. That might be it. That's kind of scary. That should be -1. I wonder how many people I've handed that to. Whew. Okay. Anyway, okay, so 3 pi over 2 is 270 degrees, and our cosine is 0. And at 2 pi, or 360, or 0, it's all the same, they're coterminal, our cosine is a value of 1. So there we got our parent cosine graph. Dun, da, da. Now, every single cosine and sine graph will start out like this. Now we can shrink it, we can stretch it, we can shove it over one way or the other, but the parent graph is this. Just like when you did quadratics, your parent graph always started looking like this. That's how it starts. And then you do some stuff to it, move it, flip it, rotate it, reflect it. All of those things that you know about transformations apply to these parent functions of sine and cosine, and tangent and cosecant when we get to those. So all of the things you know about transformations are still true. So kind of keep that in mind. As you keep working through this, remember, these are just transformations. You just have a trig function as your parent instead of a cubic or a square or an absolute value. And everything you know still is true about transformations. So that's kind of cool. Let me throw in a little bit of vocabulary, and then I'm going to stop this recording. I'll do another one for tangent and cotangent, and then I'll do another one for secant and cosecant. So that way you kind of have them chunked up into little bites. Don't forget to go back and watch my recording on how to calculate and formulate that unit circle. It is very important for you to understand where all of these numbers come from and how they're calculated. It's really easy. It's just a triangle. Y'all can do triangles. No big deal. Okay. But I don't want to put too much in one recording. So, okay, so here we've got our curves. Let me throw out some vocabulary for you because it's important for you to know. Amplitude is the height of the parent of the trig function. So amplitude, A-M-P, of course I can't ever get this to right, tude is the height. Okay, your parent function for sine is a height of 1. It always goes up to 1 and down to -1. Now, can that be changed? Absolutely, it can. So, and I'll show you what that looks like. Your period is how long does it take for one cycle to occur. So this is a cycle of sine. It goes on. All right, let me change that. Hold on. It goes on and does this. Oh, well. It goes on and does the same cycle again and again and again. It's sinusoidal. It never ends. The next cycle would be another period. So the parent period for sine is 2 pi because it takes 2 pi for that cycle to complete one time. And that's what your period is. And so sometimes this does change. Sometimes you'll get everything squeezed into 1 pi. So it just takes that graph and it smushes it together. But the period then is adjusted. So you're going to have to know how to find a period that gets squished or stretched out. It might take a period of 4 pi in order for that sine curve to start the next cycle. So those are the kind of two vocabulary words. I think there's one more. Did I share the other one? Period? Okay, no. All right, and again, I don't want to give you more than what you need. This is just a little bit. So there's more to it, but those are the two things that they're asking is amplitude and period. So let me share with you what that's going to look like in the equation if the period or the amplitude are changed. All right, let me stop sharing that and let me pull a whiteboard over here. Okay, so now we're kind of done thinking about the graphs for just a second. So let me make this one smaller. Let me make this one bigger. Whoop, there we go. All right, so if we have, oh, come on. It's not on me. Worked before, so let's just start over. It doesn't like it when you stop sharing something and then you try to use it as a whiteboard. It kind of bogs it down. Let's see if that works. There we go. All right, so if we have y equals, I think they use a b. Do they use a b or an a? I want to use the same, they use an a. Okay. I want to use the same notation as the book's using so that it doesn't get confusing. So what you're going to tell from this, and it's going to be the exact same if it's cosine, which is kind of nice because everything that's you remember for sine is the same for cosine, except the graph of the parent starts out. And I always remember cosine kind of looks like a bowl and sine looks like a roller coaster. Okay, so sine b, this is a b, just a very messy b of theta. Okay, so what are these numbers for? A, well, let me scooch this up because it doesn't matter which one. I don't want to write it twice. All right, so for either of these, this what I'm fixing to show you is true. Okay. The value of A tells you your amplitude. Okay, so if I had a 4 here, that just tells me instead of going from 1 to -1, I'm going to go from 4 to -4. That's what the A does. It's the amplitude. It tells you how tall the graph is. So it's the absolute value of A. You don't have to worry about the negative. A negative just reflects because you know that, just like with transformations any other time. And then you've got B tells you the number of cycles. Well, let's do it this way. 2 pi. Let's do it this way. I think this will make more sense. 2 pi over b, because your parent function has a period of 2 pi. 2 pi over b is going to tell you your period for your graph. How many times? What's the space that it takes to have one cycle complete? So 2 pi over b. So you'll have a number here. If it's nothing, it's 1. And you'll have a number here. And there again, if there's not 1, you assume that it's to be 1. So let me give you an example. So if we have y equals, let's do 3, we'll do the sine, and we'll say 2 theta. What does that tell me? It tells me that my amplitude is 3 and that my period is 2 pi over 2. So what I'm going to do is, let me go over here and do it on this picture right here. I'm going to change it with orange. No, let me do it with a color you can see a little better. How about this pinky color? All right, so I know I've got an amplitude of 3, and so instead of going from 1 to -1, I'm going to go from 3 to -3. There we go. I changed my height. Doesn't it look different? Doesn't it look taller? It's because I changed the marking that makes it true. Now in the book they're actually going to make you a taller graph, but you don't have to do that. You can start all of these pictures just like this and then just change your labels. So now I have a sine function with my amplitude of 3, so I took care of this, right? And now I want to take care of the 2. Instead of having a period of 2 pi, I know to calculate the period, I'm going to take this number, whatever's in front of the theta, and divide the period by whatever that number is. And since this one is 2, I'm just going to say, okay, I know that I have to half my period. So I'm going to half that, I'm going to half that, but you have to half all the markers, so don't forget that. And then you have to half that. So you got to get okay with fractions. It's no big deal. 2 pi over 2 just gives me pi. So this marking is pi. That one's done. Now 3 pi over 2 divided by 2. Remember, it's just 2 over 1. So you do the 3 halves times 1 half. You're just going to change it to a product and multiply by the reciprocal. So 3 halves times 1 half is pi, 3 pi over 4. So that's my new marking for this one. So I took my whole thing at 2 pi and I squished it down to half as big, 3 pi over 4. This one's pi over 2, so that one's easy. That one's just pi over 2. Now, pi over 2 divided by 2 over 1. We're just going to change it to a product and multiply by the reciprocal. So that gives us pi over 4. So this marking is now pi over 4. I halved each of the markings. And 0 divided by 2 is 0, so we don't have to do anything to that. So the new markings for this picture is 3 to negative 3 for my amplitude. That comes from the A. And I took each of the labels that I had and just divided by the B. And I didn't change my picture, but now I've graphed 3 sine 2 theta. And there's my graph. And so technically you would want to not have that, not have that. It's just 3 pi over 4, pi over 2, pi over 4. Okay, and that's now your new labels are there. There's your graph, and you have adjusted it accordingly. Not too bad. All right, so period, you're going to divide each of these labels by the B. Amplitude, you're going to multiply each of these labels by whatever the A is. So amplitude is the A, period change is the B, and that's how you're going to calculate that. All right, so hopefully this is helpful to you. I know that this is new concepts. You have not done this before. Please, 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 I beg you, practice. Practice. Schedule time to practice this. I know you might be able to look at, oh yeah, okay, I kind of get that. Don't go take that quiz. Do the practice. It will help you. And then when you go to take pre-calculus next year, you're going to have such a leg up because a lot of students don't have this in Algebra 2 and they get to pre-calculus and it's really hard. So this is good because you're getting a little intro to it and that's great. If you have any questions, you need any help, you know what to do, let me know. And I am happy to help. This is one of my favorite topics to talk about and to teach and to help students understand because once you get it, it's so cool because you're like, oh, I get that. It's just like transformations. And so there's a lot of information here, but you got to practice it to figure out where you're not clear. And when you're not clear, you don't understand, go back and look at the lesson. Do what you need to do. Khan Academy is great. Hotmath.com is great. There's a lot of good resources. And then let me know, too, if there's anything that I can do. I'm going to do another little recording for tangent and cotangent, and then I'll do another little recording for secant and cosecant so you can kind of see that. Make sure that you know and understand the unit circle and where it comes from because it is imperative in your work, in your trig stuff, in your trig work. So hopefully that's helpful to you, and I hope y'all have a fabulous week, and I will see you in live lesson sometime soon.